In this video, we will begin to look at information that is in the form of a string. There are many functions that come along with your C++ compiler that let you work with strings, and this will be your first introduction to those. In this program, we are going to look at 5 of those functions, and they are called length, size, find, substring, and at. Before we get into processing these strings, let's take a minute and let's just look at what a string actually means. What is string data? String data just means that it is ASCII encoded. So I'm going to bring in an ASCII table and show you some of the codes. In this table, you'll see we have 4 different parts of the table, and each one has several columns. The one over here on the left, you probably aren't going to recognize what these things are. First of all, I guess there's a column called ASCII, and then there are some other columns that represent numbers in different forms. So that's true, and that's repeated from left to right across here. In this second column, though, you will see some things that show up on the keyboard. There's an exclamation, the SP, that means it's a space, $, and so on. For each one of these things, there's a corresponding binary code, and that's given under the binary column. So this shows you the actual sequence of zeros and ones that the computer would store when you type a $sign on your keyboard. Since it's kind of hard for us to think in terms of zeros and ones, we also have different number systems that are used to represent these codes. So this binary string is 36. So it's easier for us to remember 36 as the code for a $sign. If you scroll down, then you'll see the numbers. So the number 0, it has an ASCII code of 48. The number 9, it has an ASCII code of 57, and so on. The alphabet is over here. If you go further, we have the uppercase letters, A, which has a code of 65, and Z has a code of 90. And finally, on the far left, and let's scoot that over a little bit, then you have the lowercase letters. So there's the lowercase a, and it has a code of 97. So this table then gives you the actual code that the computer will store whenever you type something on the keyboard. And this encoded information is what we call a string of information. So that's just a brief introduction to what a string is. You can always go look up more about ASCII if you want to, and we'll come back to this in future lessons. Now let's get back to the problem at hand. How do we process these strings? Well, we need a string in order to process, so here is a variable. It's a string type, and the variable is sentence, and I've just made up a sentence here. So this is a string constant. It starts with double quotes. Everything that starts with double quotes means it's a string constant. And then we have this sentence. So, CS 121 meets from 11:10 to 12:30 on Monday and Wednesday, period. So all of that information, starting with the C and terminating with the period, that is all stored internally in the computer according to those codes that I just showed you. This is what we call ASCII encoded information. So we will use this sentence in order to illustrate the different functions that allow us to process this kind of data. I've got a character called letter, and I've got some unsigned integers declared here. All right, now I've also got this thing, and if you're clever and you've noticed already, that's actually sentence spelled backwards. So that's something we'll use in an upcoming example. The program is just a shell, and it has some output statements, which will just print to the screen string processing functions, the sentence is, and they will print out the sentence. The first function that I want to show you, the string processing functions, is length. So I'm just writing cout length to the screen so we'll know which one we're dealing with. All right, now, the way that we use length is we use the name of the string, okay, the string variable. So all of these functions are connected to whatever string variable that you've declared. In this case, it's sentence. I have this variable here. It's called length as well, And that might be just a little bit confusing. So I'll tell you what, let's take that length and change it to just len, because the name of the function is length. All right, so now let's type in a command, a C++ command. Len is equal to our sentence dot length. And we have to have an empty set of parentheses here whenever we're calling these functions. So if you want to find out how long or how many characters a string has, then that's what the length function will give you. So in this case, it's going to tell us how many characters we have in that sentence. And then let's go ahead and print those out to the screen. So we get the length, and let's do a cout, double quote, the length of the sentence is, put a colon right there, and I'm not going to do an end line. I'm just going to put a semicolon after that. And then, and again, you can tell I am not a typist, so let me fix that. Okay, so the length of the sentence is, and then I'm going to print out the actual variable len, len for the length, and then we'll do our end line here. All right, so then will give us the length of the sentence, and we'll print that back out. I don't want to go through and print out the rest of this stuff, so as you've seen in previous examples, I'm going to insert a system pause here so that the program will stop at this point. And again, this is a Windows command. It's not part of C++. So if you're not using Windows, then you don't need to use this. Now, just given that much, let's compile the program, run it, and let's see what the output is. The program compiled, and it is running, and here is the output. So let's move things around a little bit so we can see the code. Okay, so that's what's important. Now let's look at the output. All right, so we get string processing functions, the sentence is, and this just prints out the sentence. Then we are working with the length function, so we get the length, and then we print out the length of the sentence, and it is 57. So something important to note here is that the variable that we use for length, it must be an integer, because the length function returns an integer, which will be how many characters there are in the sentence. You can count those if you want to, but I can assure you that there really are 57 characters beginning with the C and ending with the period. So the length function is very easy to use. It tells us how many characters we have in a sentence. Okay, now let's move on to the next one, which is size. I'm just going to continually do this as I go through the program. I'm just going to move that system pause down as we do each one of our examples. The next thing is going to be the size. All right, so the size is also going to be the same thing really as length. It'll tell us how many characters there are in the string variable that we are measuring. And I'm going to do this a little bit differently. I'm going to show you can embed this into the cout statement itself. So let's do cout, and let's do a double quote, the size of the sentence is, and we'll put a colon there, tab, and then you can directly insert these functions as part of your cout statement. So I'll use sentence dot size, and we need the double parentheses here, and then we'll put an end line. So you can reference these, or you can use these functions within a line if you want to. So we didn't have to save the size in a variable. Whenever we want to print it out, we could just embed that directly in a cout statement. Or if you needed to use it somewhere else in a computation or if statement, then you can also just directly embed it if you want to. Alternately, if you want to save it into a variable, then you could write another assignment statement as we did with the length. Now let's run the program and let's see what size is going to give us. Now we have the output, and you can see that from the statement where we used the length function, then we had 57 here, and then from here where we use size, the size of the sentence is 57. So really, these are interchangeable. You can use size or you can use length. They both give you how many characters you have in a string constant. Now, let's move on to the next function, which will be a bit more powerful. Now we'll look at the find operation or function. Let's pull the system pause statement down a little bit further, and we'll look at find. Well, what does find do? Let's write a little comment here. It will find the position of a substring. So if we have a substring that we want to look for, then the find operation will do that. And let's take an example where we're looking for something inside sentence. And it's going to return the position where that substring begins. So let's go ahead and write the line of code here. So I've got an unsigned integer position as a variable equals sentence dot find. And in this case, we don't have empty parentheses. We want to put in the substring that we're looking for. So I'm going to look for the substring 121. And I'm going to spell sentence correctly. And then we have a semicolon over here. So this is the way find works. And really all of these functions, again, they work by attaching themselves to whatever the string variable that you're working with happens to be. So sentence.length in this case. And if you had another variable that is named differently, it's whatever that variable name is and a dot and then the function. So length works that way, size works that way, and find works that way as well. So that's how all these things are going to work. That's the syntax for how you would use them. This one is going to look through our sentence and it's going to try to find the substring 121. Now I can see that 121 shows up right there in the sentence. So it will print out the position of the 1 in the leftmost 1 in 121. So that's what find does. It returns the position of that substring. So let's print that out. So we'll have a cout statement. Okay, the substring, the double quote there, the substring 121 starts at position, and then I'll just print out the position. Then an end line. So we can have our find function look through our string, and when it finds this substring, it will return whatever position that is, and then we can print it out. All right, so let's run the program and let's see what we get from find. Now we are running the program, and these other things are just going to be from the previous cout statements we did with the length and size. But under find, we get the substring 121 starts at position 3. Position 3. Well, okay, let's go up and let's look at the output where we printed out the sentence. Then here's 1, 2, 3, 4. So it looks like that the 121, that leftmost one, should be at position 4. But instead we get position 3. Well, if you've had some experience with computer science, you know that in computer science we don't start counting at 1, we start counting at 0. So what this is really saying is the C is at position 0, the S is at position 1, the blank is at 2, and then position 3 is where the substring 121 begins. So find is going to tell us where that substring appears within our overall big string that we're calling sentence. Well, let's look at some other stuff that can happen with find. Let's move on from here and let's do something else with this. All right, so let's say we're looking for something that isn't in the larger string. All right, so what if we have, okay, position is equal to sentence dot find, and let's suppose I'm looking for the string 1, 2, 3, 4. Then we need a semicolon at the end. Then let's print out the result of that position. So I can copy that cout statement and I'll paste it in here. And I'll just change this up a little bit. Change it up a little bit. So 1, 2, 3, 4. So the substring 1, 2, 3, 4 starts at position and it will print out that position. All right, well, we already know that 1, 2, 3, 4 does not exist anywhere in there. So what is it going to give us in this case? What does find do? Well, we can always run the program and print it out, and let's see what we get. So I'll compile it. Well, the program is now running, and if you look at the last couple of lines here, then you can see that those last two cout statements that we did, the substring 121 starts at position 3. So we know that's right. 121 really is up here. It's part of the sentence. 1, 2, 3, 4 isn't in the sentence at all. So find tells me that it's at this position here, which is a gigantic number. Well, this is what we use to test in situations where we're looking for something in a string, but it doesn't exist. So that is an important thing to remember. If you are searching for something that's in a string constant, or in a string variable for that matter, then if it isn't found, then find is going to return a very big number. And we have a special way that we can test to see if we get that number. We don't have to actually remember the number. So this then gives us a way to test to see if we find something or if we don't. So that's what we will look at next. Now let's go back to the code and let's modify it a little bit. So I'm going to separate the cout statement where we did find something from the one where we didn't. Now, let's add something so we can test for the condition where this string isn't found. So we know that the position is going to be that really big number because 1, 2, 3, 4 is not in the sentence that we began with. You should always do this. After you do a find operation, you need to test to make sure that you did find it, and then you need to do something either if you did or if you didn't. That means we need an if statement. So let's do if position is equal, and we don't have to remember the great big number here. We can use something special that's built in, and in fact you should do this because the number might be different on different computer systems. Here's a special thing. It's called string. We have a double colon, and then NPOS. That's just one big positive number. That's what that means. So if the position is equal to this great big number, that means it isn't in the string. So we need to have a different cout statement for that. Let's do cout, okay, double quote, the substring 1, 2, 3, 4 was not found. All right, so we print that out. And let's do an end line here. All right. Then if we did find it, then we'll print out the other message. So we can just put an else here. And then let's go ahead and indent the cout so we have a nice if statement. So we look for the substring 1, 2, 3, 4. And if we don't find it, we get the great big number. The position is equal to the great big number. We print out that we didn't find it. Otherwise, we have found it, and we'll print out the position where it begins. So this is something that you should always do with the find operation. Now, let's move on, and actually, let's go ahead and test this. We need to run the program and show you the output from this. So I'm going to compile and run the program. Here's the output. And if you look at the bottom, then here's the line where we found 121, but the substring 1, 2, 3, 4 was not found. So that comes from this cout statement right there. So now we can detect and print to the screen if we find it or if we don't. Now, let's go ahead and let's continue with this, and we'll look at some other things you can do with find. And in particular, what if you're looking for some repeated occurrences of something? And in this case, I'm going to look for the substring 12. So there's a substring there, and there's another one over here. So what do we do in those circumstances? Okay, well, let's modify the program to do that and further explain the find operation. Now let's look for the substring 12. So we'll just put that in here. after that else statement. So position equals sentence.find. This time, I'm just looking for the 12. So double quote 1, 2. That's the substring I'm trying to find. Then let's print that out. And I can go borrow this cout statement up here and modify that a little bit. So the substring 12 starts at position and then will output that position. Okay, now I just told you you should always do the if test when you're doing a find operation, and you should. We should actually include that here. But I want to illustrate something else, so I'm not going to take the time to do it. But that's because I know the 12's in there, so I know I'm going to get something. So we'll do this, sentence find 12, and then we'll print that out. All right, well, great. I want to find the other one as well. So let me make a copy of that. I'm going to make a copy of those two lines, and I will paste it here. Then maybe this will give me the position of the first occurrence of 12, and maybe this will give me the occurrence of the second one, so I can find both of those substrings. Do you think that will work? Let's compile it and find out. We'll look at the result we get. The substring 12 starts at position 3. That comes from the first find, and I try to find it again. It still gives me position 3. So the way that find works is it doesn't move past the substring when it encounters one. So it will always find the position of the first occurrence. So that's another way that you need to remember that the find operation works. So we can do find 12 as many times as we want using sentence, but it's always going to give us position 3. There must be a way to find the other one you're saying or thinking. And you're right, there's another way to test for this. And that's another variation on the find function. So I'll show you how to do that. Let's move back down to where we were looking for the substring 12. And if I modify this second one, position equals sentence.find 12, I'm looking for the second one. You can add an additional argument in here. So after the substring, you can put a comma, and then you can tell it a position within the string to start the search. I know that the position for 12, the first one is 3. So if I start at position number 4, then it begins searching at position 4, looking for the next occurrence of 12. So you can use that in order to search for multiple occurrences of the same substring. Now let's go ahead and compile and run, and I'll show you the result of this one. Here's the output. So now notice the difference. Substring 12 starts at position 3. So that was from the first find up here. Then the next one, we find that the find function says that the substring 12 starts at position 27. So now we do find both of them. And let's go ahead and count. So let's move up from the output and let's look at those. So we know that that's 1, 0, 1, 2, 3. So that's the first 12. Then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and 27. I might have missed a count in there somewhere. At any rate, this one is at position 27, so you can count and verify that. Remember, start counting at 0. So that's how you can modify the find function to find multiple occurrences, but that's still not quite the ideal. So let's close this, and instead of hard coding the 4, then let's see if we can use a variable there. We never like to hard code things if we can get by without it. So from the first find operation, that gave us the position 3. If I replace this 4 when I'm doing the second find with the variable position plus 1, that means it will begin searching from the position of the last 12 plus 1, which in this case is going to be 4. But in general then, the 12 could be anywhere, the first 12 could be anywhere. It returns the position for that. And the next find will begin at that position +1, looking for the next occurrence. Now this will also give us the exact same result, but let's run the program to verify that. So here is exactly the same output. So this time I'm using the variable position, which was 3 from the first find, add 1 to that to give us a 4, and then the find begins at position 4, and it gives us the position where it finds the next substring 12. This is really handy because if you have multiple occurrences, if you don't know how many you have more than 2, then you could put this in a loop and you could continue to look for all the occurrences of 12 until you get a position that's this big thing up here, which would tell you when to leave the loop. I'm going to modify this program by putting in those if statements, and I'll just do a copy and paste, and you will not have to watch me type everything that's going on here. But every time you do a find, you should go ahead and test with the if statement. So I'm just going to copy that, paste it, and put it in, and then we'll come back to the program. So I will pause while I'm doing that so you don't have to watch me doing all the typing. Okay, so I did that. Let's just take a quick look at what I did. What I did was to just go ahead and add the if statement for each one. So the first time I'm looking for 12, and here's the test. If we didn't find it, then we'll print out that it was not found. If we did find it, we'll print out the position. And the same thing for the second search of 12, where we're testing, we're looking for it here. I added in that if statement. So always do that. Always do the if test, because you do not know if your program's going to find an arbitrary substring within another arbitrary substring, and this will give your program the ability to handle each of those occurrences. If you don't do this, if you're expecting to find a position and it comes back as some huge number, and you want to do something down here, some calculations with it, then you're likely to get errors because that huge number isn't going to work for most things. Now, let's move on to our next string processing function. The find function doesn't actually extract any information. It just gives us the position where a substring occurs. Now let's look at a function that actually lets us make a copy of the substring and save it as a separate piece of that substring. So this cout statement, let's see what I need to do here. Let's remove a little white space. This cout statement says the substring of 10 characters at position 7 is. Well, let's directly call the substring function and print that out here. So I'm going to modify this a little bit. I just got to hit the enter key here. And before we do anything further, I am going to call the substring function. So sentence.substring. And the substring is abbreviated. It's substr. And it has 2 arguments. The first one is going to be the position within the string that you want to begin. So this says we want position number 7. And the second argument will be how many characters do you want from that position onward, and in this case we want 10. So I will pull those out, print them, and then we'll have the end line right here. All right, so what that means then is when you want to use a substring function, then you can directly print it out here, or if you have another variable of type string, you can save that substring into that variable, and we'll do that next. But the substring function itself, remember, it's substr. First argument is the starting position, and the second argument is how long do you want the substring to be. So this will extract it and print it out directly. Let's build a program and run it. Now here is the result. Looking at the last output, it is the substring of 10 characters at position 7 is : meets from. Well, okay, let's see exactly if we can pick that up. So 10 characters starting at position 7. Let's find position number 7. And here's 0, 1, 2, 3, 4, 5, 6, 7. So this is the beginning position. And the substring then is going to pull out the next 10 characters, including the one at position 7. So that's M is the first one. So that's M, and then 2, 3, 4, 5. The space is 6, 7, 8, 9, and it stops there with the M in from. So here we have those 10 characters that have been extracted from the main sentence and printed to the screen. So this can be very useful if you're trying to pull out information from a particular position within a string. Then you can use find to find the position, and then you can use a substring to extract that substring. Now, let's modify this a little bit, and let's suppose we want to save that information. So let's modify the program, and instead of just embedding it here, we will have a variable that we can use for that. So let's scroll up. I like to put all my variables up at the top. So I'm going to go back up to the top, and I'm just going to add another string variable. Okay, string. I'm going to make it part, P-A-R-T. And to be robust, I guess, or thorough here, I should initialize it to something. We should generally always initialize our variables, and this would just be the null string. So now I want to save that substring into part. So let's scroll back down. And before we do the cout statement, I'm just going to have part is equal to, and then I'm just going to let the substring function work here. So I'm going to copy it, or actually cut it from there and put it here with a semicolon. And then, instead of doing the embedded part, I can use the variable part here in my cout statement. So it's likely that you would want to do a substring, pull out a substring, and save it into a variable. So this illustrates that you can do that. And I'll prove it by building and running the program again. Here's the output, and you can tell we get exactly the same thing. So I just replaced the embedded version of the substring function with the assignment statement that saves that substring into another variable, and then we print out that variable. Now, it's important to remember that the substring function does not delete the characters from the sentence. It just makes a copy of them and saves them into a different variable. All right, so now let's move on to our final example of the string processing functions in this program, and that one is called at. All right, so I'm going to move my system pause down. In fact, I'm at the end of this, so I'm just going to delete the system pause altogether. So the final one is at, just the short little 2-letter word at. The character at position 20 is. So if you want to access a particular character, then you have the ability to do that. And I'm going to scroll back up and remind you that I did have a character variable which is called letter up here. So I'm going to use that. So scrolling back down again, then let's extract just one letter. All right, so letter is equal to sentence dot at, and then what position do you want that character to come from? So you just put that in here in parentheses. So this will extract the letter at position 20, and then we'll print that out. Let's add this to our cout statement, letter, with an end line. So this will find the character at position 20, and it will print it out. So don't worry about this reverse the sentence. We're not going to do that in this video. We'll do that in an upcoming video, so I'll just erase that. So now let's build the program and let's run it. Here's the output, and at the bottom we see the output statement, the cout statement. The character at position 20 is, well, the colon comes from the cout statement. The actual character at position 20 turns out to be another colon. So if you count over starting at position 0, you'll find that the colon between the 11, 10 is at position number 20. All right, let's do another example of this, and let's pick out a different position. We know that M is at position number 7 there. So let's change our program and print that out. It's be a little bit more exciting than printing out a colon, I suppose. But anyway, let's do it. So we'll stop the program and we'll run it again. Well, I'll run it again after I change that position. So I'm going to make that 10 instead of 20. There we go. All right. And let's change that comment to 10 as well. Okay, now let's compile and run the program. Well, the output isn't the M, it's the T, so let's take a look at that. The character at position 10 is the letter T. Well, okay. It wasn't an M after all. I can't count. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and sure enough, there's the T. So this at function allows you to extract a particular character from whatever position. The thing you should remember about that is that the at statement or function, it returns a character. A lot of these things return different types. Okay, so when you're saving the output from the at statement, then you need to save it as a character. If you have a substring, then if you want to save that into a variable, substring returns a string. So this thing needs to be a string. And if you're looking for something with find returns a number. It returns an integer value. So make sure that when you're declaring the variables that they are the appropriate types. Otherwise, you'll have a type mismatch on these things. And going all the way back up to the top, then the length as well as the size, those things will also give you a integer as a return value. Well, now, just a couple of more comments before I go. In the substring, I have hard-coded 7, I've hard-coded 10. Of course, those can be variables. They just need to be variables that are of integer types. So you can start your search at something and you can end it with that many characters, or that is, you can start with a position here and get that many characters. Those can be variables. Okay, same thing down here. If you wanted to use at with a variable, and you could use the at statement as well there. This thing is equivalent to something you might have seen already. So I want to show you something that's exactly the same as the at before I close this out. We can also do this. We could do letter is equal to sentence, and you can use a square bracket notation here and put the position in. So this is treating sentence as an array of characters instead of as a string. So the at is a string processing function. It's part of the string library. And this is equivalent. This is just accessing through an index the character string that is that sentence makes up. So both of these give you the same output. Alrighty, I think that's enough for this video, so we will stop here and we will continue with string processing in upcoming lessons.